All right, so we're going to start going through trig review. Remember that Monday is your opportunity at lunchtime, and you'll be able to start after the review that we do. But that's your opportunity to do the Unit 3 rewrite on exponential and logarithmic functions. You should have picked up the review assignment, which is at the front here if you want that opportunity. Wednesday at lunch will be the opportunity to do the trig reassessment. So I will have that for you to pick up today if that's what you want to do. Also remember that tomorrow is the last day to hand in any missed assignments. No extensions, no excuses. Even though there's no school tomorrow, you can still scan and email me those. I'll print them off and mark them. And next Friday, a week from tomorrow, is your diploma exam. And I said this before, it'll be the toughest diploma exam that you write. It's hard. No two ways around it. So you should be preparing to the best of your ability. Okay? No one here has time to waste getting ready for that exam. It's going to require you to really focus, spend as much time as you can reviewing and studying because it's not going to be easy. I guarantee that probably 95% of you will look back after you walk out of that exam and have regrets that you didn't spend more time reviewing and studying because it's not going to be easy. But if you're well prepared, then you should do fine. That's in your court, though. So, trigonometry, probably the toughest unit as a unit, I would say, because there's a lot that you need to know for trigonometry. There's usually a question on the diploma exam where you have to convert from degrees to radians or radians to degrees. It's an easy mark, a gift mark, because there's only two things that you have to do. You have to remember that if you're going from radians to degrees, the number of degrees as a number will always be a bigger number than that angle is in radians. To go from degrees to radians, you have to get smaller. To go from radians to degrees, your answer gets larger. You're either going to multiply by pi and divide by 180, and that'll make your answer get smaller because multiplying by pi, which is just over 3, and then dividing by 180, well, your answer is going to get smaller. So you would do that if you're going to go from degrees to radians. If you're going from radians to degrees, your answer has to get larger. So in that case, you'd multiply by 180 and divide by pi. The only other thing that might happen is like this first question, where you have an angle which is in radians because it's in terms of pi, and you want to go to degrees. This one is done simply by letting pi radians equal 180 degrees. When we first started looking at the unit circle, that was something that we talked about. That pi radians is the same as 180 degrees. It's halfway around the circle. And one full rotation around the circle is 2 pi radians or 360 degrees. Okay, so you can just go to your calculator and do this. The other thing you can do is 4 goes into 180 45 times, and then it's 15 times 45. So 15 times 45 is 675 degrees. And so there's the answer. So if this was a numerical response question, remember there are 4 boxes. You always you work left to right. In this case, the last box would be left blank. But that's not what the computer marks. It marks what you bubble in below. So that's what it's looking for. You've got 6 hours to do this exam total. So take the time to go back after and check all your bubbles, making sure that you bubbled in the numerical response questions correctly as well as the multiple choice questions. Number 2, an angle in radians that is coterminal with 30 degrees. So coterminal means it has the same terminal arm. It ends up at the same spot on the unit circle. So Our angle is in degrees, but the four choices we have are in radians. So 30 degrees is approximately right there, which is pi over 6 radians. So we want to state the angle that's coterminal with pi on 6. If you look at the four choices that we have, negative 5 pi on 6 is not coterminal with pi on 6. Negative 5 pi on 6 would be about right there. It goes in a negative direction, which is clockwise, and it's 1 pi on 6 short of pi. Pi would be halfway around the circle. Okay, Tyson, put that away, okay? Put it away. Or go, or just leave. If you're not going to pay attention, those are your options. So that's not coterminal. Then we have negative 13 pi on 6. So again, the negative means we're going clockwise, 13 pi on 6s. One trip around the circle would be 12 pi on 6s in a clockwise direction. We would have to go one more pi on 6 past that, which would be right there. That's where negative 13 pi on 6 would be. Did you sign in, Simmer? Okay. So that's not it. 7 pi on 6. Well, that is a positive angle. It is going counterclockwise. 7 pi on 6. It would be coterminal with negative 5 pi on 6. Because it is 1 pi on 6 past 6 pi on 6. 6 pi on 6 is pi. So that angle is coterminal with negative 5 pi on 6. So that only leaves us with the last one, 25 pi on 6. But we'll just make sure that that one does in fact work. Once around the circle would be 12 pi on 6s. That's 2 pi. Another trip around the circle would be 24 pi on 6s. And then one more pi on 6 takes us to 25 pi on 6. So that is the correct answer. All right, this next one, again, multiple choice. That angle theta in standard position is shown below. The best estimate for that rotation angle theta in radians would be what? Well, it's partway between pi radians and 3 pi on 2 radians. Did you sign in, Chase? Okay. So remember that pi radians is 3.14. So our answer has to be bigger than 3.14. So we can eliminate those first two. Because it has to be bigger than pi radians, which is 3.14. It's less than 3 pi on 2 radians, which, if we see what that is as a decimal, is 4.71. It doesn't matter what mode your calculator is to calculate that. The only time the mode matters, whether you're in degrees or radians, is if you're taking the sine, cos, or tangent of an angle. Then mode has to be correct. But in this case, we're not taking sine, cos, or tangent. So the angle is between 3.14 and 4.71. Can only be C. Number 2, Mary is given the diagram below showing a rotation angle of 120 degrees. The arc length of the sector is 40 centimeters. There are 4 statements there. We want to figure out which 2 are correct. The first statement says that the radius to the nearest centimeter is 19 centimeters. So to do that, you'd have to use the arc length formula. And the arc length formula says that theta equals A over R. However, theta must be in radians to use this formula. So you would have to convert that 120 degrees to radians as your first step. And remember that the number that describes the radians is always a smaller number than the equivalent value in degrees. Our answer has to get smaller. So we would have to go 120 degrees, multiply by pi, and divide by 180. You could also use what you know about the unit circle to see what 120 is in terms of radians, okay? Or you can use this method here. Because these are both divisible by 60, which would give us 2 pi on 3. And that's an exact value, right? If you do it by multiplying 120 by pi and divide by 180, you're going to get a decimal that will need to be rounded. But it would still work because you would check to see if the answer that you get is close to 19 centimeters for the radius. So 2 pi on 3, which is theta, equals a the arc length, which is 40, over r the radius. So we'll solve for r. We'll cross multiply. 2 pi r equals 3 times 40 is 120. And then we would divide both sides by 2 pi to get r. So on our calculator, 120 divided by, in brackets, 2 pi, which is approximately 19.1 centimeters. To the nearest centimeter, that would be 19. So this is a correct statement. One of those two spaces would have the number 1 in it. Statement 2 says equivalent rotation angle is 4 pi on 3. Well, that's not right because we just found that it's 2 pi on 3. We just did that as part of determining what the radius was. We converted the 120 degrees to radians. It's 2 pi on 3. Statement 3 says if the arc length increases to 80 centimeters, the central angle would be 240 degrees. So this is essentially saying that if the arc length doubles, the central angle would double. So it kind of makes sense, but to make sure, let's actually calculate. We've already know that our radius is 19.1, so we can find out what the central angle is in degrees by using the arc length formula and getting it in radians and then converting. So it would make sense that if the arc length doubles, the central angle will double as well. But we should check to make sure. So we will do that. So if the arc length, again, the formula that we use is theta equals a over r. So if the arc length doubles to 80 centimeters and the radius stays 19.1, let's see what theta is. So using our calculator, 80 divided by that previous answer is that many radians, 4.1888 if we round it. But that's in radians. And then to convert that to degrees, we have to get bigger. So we'll multiply by 180 and divide by pi. Times by 180 and then divide by pi. We get the right angle. So that is a correct statement. It made sense that that would happen, but check to make sure. Statement 4 is not correct because it says that Mary can determine the radius by dividing the given angle by the arc length. The given angle is in degrees. So that's why it won't work, right? We've got that formula that theta equals a over r. So if we want to solve for r the radius, we can multiply both sides by theta and then multiply both sides by r and then divide by theta. So you can find r the radius by dividing the arc length by theta, but theta must be in radians, not degrees. And the given angle is in degrees. So the statements that are correct are 1 and 3. In this case, The computer would be programmed to accept either 13 or 31 as the answer. It doesn't tell you what order they are to be written in. Most would write it numerically, but you don't have to. They can do that on the diploma exam. They can program the computer to mark two answers for one question. In this case, either 13 or 31, if that was a numerical response question. And so whether you go 13 or 31, those last two boxes will be left blank. This next question, a circle with radius r, an arc length of 34 pi, and those two central angles is shown below. The value of A in the angle pi on 15 has two digits. The coefficient of pi in that top angle has two digits, B and C. The length of the radius, R, of that circle will also be two digits, D and E. In this case, they need you to figure out what B, C, D, and E are respectively, so that means you have to write them in that order. You can't mix up the order on this one because that word respectively is used. So we need to find two things. We need to find what that top angle is. It's smaller than that bottom angle. As well, we need to find the radius of that circle. So that 34 pi would be known as a major arc because it is a longer arc than the one going from, if we label those two sides A and B, if you go from A to B in a clockwise direction, that's a much further distance than if you go, counterclockwise. No, clockwise is right. But if you go from A to B in a counterclockwise, no, I had that wrong. A to B this way would be counterclockwise. That's much longer than going A to B clockwise. So the bottom one is known as a major arc. The top is known as a minor arc. But no matter which way you go around the circle, it takes 2 pi radians to do one complete revolution. So if we add these two angles together, a pi over 15 plus 17 pi over 15, that has to equal 2 pi. Those two angles together will give us one complete revolution around the circle. So this is how we determine what A will be. It's going to be a two-digit number, the coefficient of pi from that first angle. So A pi over 15 can be found by going 2 pi, which would be 30 pi over 15. We need a common denominator here to subtract these two. So we need to write 2 pi with a denominator of 15. That'll be 30 pi on 15. 30 divided by 15 is 2. And when you subtract those, you're going to get 13 pi over 15. So A equals 13. It is a two-digit number, and those values are the values of B and C, which are the first two numbers we need to write below. So that's 1 and 3. The second thing we need to do is we need to find R, the radius. So to do that, I'm going to use this bottom angle of 17 pi on 15 and the major arc of 34 pi. So again, theta equals A over R. Theta is 17 pi on 15, and that equals A, the arc length, which is 34 pi over R. Now in this case, you could cross multiply and then solve for R, but you don't have to because if you compare the numerators, if you compare 17 pi and 34 pi, obviously 34 pi is twice 17 pi. So we can get R by just multiplying the bottom number by the same scale factor. And R would be 30, twice 15. So there's the code for that one. All right, next question. The point P, coordinates 0.2 comma K, lies on the circle with a radius of 1. The exact value of K could be expressed as plus and minus root B. What is the value of B to the nearest hundred? So B would be the number under the radical there. This is done because it's on a circle with a radius of 1, which means that's our unit circle, right? So if we put a circle here, and we are told that P has an x value of 0.2. So it could be up there or it could be down there. An x value of 0.2. In the first quadrant, K would be positive, but in the fourth quadrant, K would be negative. We need to find out what the value of K is, and it can be expressed as plus and minus root B. We need to find out what that B is. So again, because this is a unit circle, the radius is 1. We can construct right triangles here. By dropping that line from the end of the terminal arm straight to the x-axis. And the base of these two triangles will be 0.2. To get to those two terminal points, you're going 0.2 units to the right. So we can find out what the missing side of the triangles are by using Pythagorean theorem. 0.2 squared plus y squared has to equal 1 squared. When you square 0.2, you get 0.04. And squaring 1 obviously is 1. So you'll subtract the 0.4 from both sides and get 0.96, and then take the square root, and you'll get plus and minus the root of 0.96. This question is asking us to write what B is. It's the number under the radical, which is 0.96. And that is the answer to 2 decimal places, the nearest hundredth, which is what we're asked to do. So again, on the exam, you would put the 0 in the first box. There are places in either the second, in both the second and the third box, you can put a decimal. There are spaces below the second and the third box to bubble in a decimal. Those are the only 2 spaces where you can do that. So you'd actually have to physically bubble in the decimal below that second box. On the scan sheet, below the second and third boxes, there are spots where you can put a decimal. All right, number 7. On the unit circle, that point lies on the terminal arm. In standard position, what are the exact values of these 6 trig ratios? So because x is negative and y is positive, that puts us in the second quadrant. So this is the point negative 513, comma 1213. And when we've done this, we've always drawn a reference triangle by drawing a line straight to the x-axis, which gives us a right angle down there, and our reference angle theta is between the terminal arm and the x-axis. Remember that the first number from the coordinate is always the cosine of the angle. The cosine is negative 5/13, and cosine is adjacent over hypotenuse. The second number is the sine ratio, and sine is opposite over hypotenuse. So now we have all three sides of the triangle labeled. And we're asked to state the 6 trig ratios. The sine of theta, well, again, that's 12/13. The point tells us that. The cosine of theta, again, that's negative 5/13. The point tells us that. But the tan ratio, we'd have to use opposite over adjacent. 12 over negative 5, negative 12/5. The cosecant of theta is the reciprocal of sine, 13 over 12. The secant of theta is the reciprocal of cosine, negative 13/5. And the cotan is the reciprocal of tan. It'll be negative 5 over 12. So there are the 6 ratios for that one. Number 8, you're given what the secant is, and you're also told that you're between pi and 3 pi on 2. So that would put us in the third quadrant. So again, we draw a terminal arm in the third quadrant. We draw a line straight to the x-axis, which gives us our right angle. Theta is always the angle between the terminal arm and the x-axis. We're told that the cosecant of theta is negative 8 over 5, which means the sine of theta would be negative 5 over 8. And sine is opposite over hypotenuse. The hypotenuse is always positive, which means the opposite side would be the negative, which makes sense because we're going downwards from the x-axis. We want to find the exact value of tan theta, which means we need to know what the length of the adjacent is because tangent is opposite over adjacent. So we can find out what x, the adjacent side, is by, again, using Pythagorean theorem. So x squared plus 25 will equal 64. So x squared will equal 39, and x will equal the root of 39. But because it's going left from the origin, it'll be negative root 39. So the exact value of the tan of theta, which again is opposite over adjacent. A negative divided by a negative is a positive, and normally we write them with not a radical denominator, but a rational denominator. So you'd multiply both top and bottom by root 39 to rationalize the denominator. So there's the exact value of the tangent of theta. Determine the exact value of that expression. So that would tell us that we're using the unit circle. So you're going to have to know this for the exam. You're not given the unit circle. And we've done this using reference angles. But it comes from the first quadrant of the unit circle. So at 0, the coordinates are 1, 0. At pi on 2, it's 0, 1. At pi on 6, or 30 degrees, and remember the hand trick. Okay, pi on 6 is here. root of this many fingers over 2, comma, root of this many fingers over 2. Root of 3 over 2, comma, root 1, which is 1 over 2. Let's skip to pi on 3, or 30 degrees. So put down that finger, the root of this many fingers over 2, root of this many fingers over 2. Root of 1, which is 1 over 2, root 3 over 2. It is the exact opposite of what we wrote for pi on 6. And then for pi on 4, root of 2 over 2, comma, root 2 over 2. So for the sign of negative pi on 6, that will put us in the fourth quadrant, where sign is negative, because that's the C quadrant using the cast rule. The sign of pi on 6, remember sign is the second value, is 1/2, but in the fourth quadrant that would be negative 1/2. Plus the cosine of 7 pi on 4. 7 pi on 4 is also in the fourth quadrant. It's a pi on 4 short of 8 pi on 4, which would be 2 pi. So the cosine is positive here, and the reference angle for pi on 4, the cosine is root 2 over 2. So these two have a common denominator of 2. We can combine the numerators. Makes sense to put the positive term first, followed by the negative term. Whoops, that's not root 2, that's just 2. So there's the exact value of that. Now you can use your calculator to check this. In this case, you do need to be in the radian mode, because we're taking the sine and cosine of angles that are in radians. So if we're going to check our answer, we'll need to be in the radian mode. We'll take the sine of negative pi on 6, close the bracket, plus the cosine of 7 pi on 4, close the bracket. It equals that decimal, that irrational number. Well, that should be equivalent to the answer that we got. So in brackets, if I go root 2 minus 1, close the bracket, divided by 2, get exactly the same decimal. So that shows that the answer we got is correct. Number 10, if the tan of theta is 5/2 between 0 and 2 pi, then the largest positive value of theta to the nearest tenth is what in radians? So this is basically solving a trig equation. That's what we're doing here. There are two quadrants where tangent is positive, and that's where we start. This comes from our cast rule. Tangent is positive in the first quadrant because they're all positive there, but also in the third quadrant. So the largest one will be the one in the third quadrant. This is the angle that we're looking for. Obviously, that rotation angle will be larger than one in the first quadrant. So to do this, we need to know what the reference angle is. And to do that, our reference angle theta can be found by going tan to the negative 1 of 5/2. And again, because we want our answer in radians, our calculator needs to be in radian mode, which it is. So if I go second function tan of 5 over 2, this gives us our reference angle in radians, 1.19 radians. And that goes between the terminal arm and the x-axis. That's where the reference angle goes. So our rotation angle is that many radians past pi. Pi is halfway around the circle. Our reference angle goes past that. So we just have to add pi to that number now. And that'll give us our rotation angle to the nearest tenth would be 4.3 radians. So again, if this was a numerical response question, you'd have a decimal in that second box, and the last box would be left blank. Okay? This next question, you've got point A with coordinates root 3 over 2, comma, a half, and B with coordinates negative root 2 over 2, comma, positive root 2 over 2. So you should recognize those 2 points from the unit circle. If these are the coordinates on the unit circle for part A, this is pi on 6 radians. And a reference angle of pi on 4 would have these 2 numbers. Again, we can go back and look at the unit circle that we just constructed. Or maybe it's above here. Yeah, it is. So those numbers come from a reference angle of pi on 4. So the only difference is now we're in the second quadrant, but our reference angle is pi on 4. So what's pi on 4 short of pi, which could be written as 4 pi on 4 minus pi on 4. That rotation angle is 3 pi on 4. So those are 2 different angles in standard position. The angle theta, which you see is the angle between these 2, can be expressed in the form a pi over b. What are the values of a and b respectively? So the order matters. That means a first, b second. And that can be found by taking the 3 pi on 4 and subtracting the pi on 6. So to subtract those, we need a common denominator of 12, which means you'd multiply this by 3. It'll be 9 pi on 12 minus, here we multiply top and bottom by 2. So it'll be 2 pi over 12. That gives us 7 pi over 12. And so A would be 7, B would be 2-digit number 12. And so the last box would be left blank here, if this was a numerical response question. Okay? Each of the trig ratios listed below results in a value of 0 or it's undefined. Use the following code to indicate whether the ratio is 0 or undefined. If it's 0, code of 1, undefined, a code of 2. You want to write the code for each of these. This can be done just by using the graphing calculator. With the calculator in radian mode, take the tangent of pi on 2. You get an error, which means it's undefined. And that is a code of 2. Take the cotan of 3 pi on 2. So to do that, you have to do the tan of 3 pi on 2, because there is no cotan button in your calculator. That gives you an error as well. But remember where that error comes from. Okay, let's go back to pi on 2. If you look on the unit circle at pi on 2, the coordinates are 0, 1. Down at 3 pi on 2, it's 0, negative 1. Tangent is sine over cos. So the reason that you get an error for the tan of pi on 2 is because you're taking the sine of pi on 2 and dividing by the cosine of pi on 2. You're going 1 divided by 0. That's why you get an error. That's why it's undefined. Okay? So the tangent of 3 pi on 2, something similar is going to happen. You're going to go sine divided by cos. You're going to get negative 1 over 0. That's why you get an error. But the cotan of 3 pi on 2 would be the reciprocal. It would be 0 over negative 1, which is 0. The cotan of 3 pi on 2 is 0. And so that's a cot of 1. The sine of pi, well, you can use your calculator for that. The sine of pi is 0. That comes from the unit circle. There's pi radians there, and the coordinates there are negative 1, 0. Sine is the second number. So that value is 0. That would be a cot of 1. And the cosecant of 2 pi, well, 2 pi is over here. The coordinates there are 1, 0. The cosecant is the reciprocal of sine. So if we take the sine of 2 pi, you're going to get 0, which is the same as 0 over 1, to write it as a ratio, 0 over 1. So to get the cosecant, you take the reciprocal, and you would get 1 over 0, which is undefined. So that would be a cot of 2. If you did it on your calculator, the sine of 2 pi will give you 0, but if you take the reciprocal of that, you get an error. So it's undefined. There's the answer for number 12. Number 13, you've got 4 statements there. Which of those 2 are true? So those angles, pi on 6, 5 pi on 6, 7 and 11 pi on 6, they will all have the same reference angle of pi on 6. That is a true statement. In degrees, this is saying 30 degrees, 150, 210, and 300. So if we look at them on the unit circle, and you can do it by finding them on the unit circle, or you could also do them by taking these 4 angles and write them in degrees, which can be done by simply letting pi equal 180, because pi is equal to 180 degrees. So 180 divided by 6 is 30. So that is the correct angle. 5 times 180 divided by 6 is 150. So that one is correct. 7 times 180 divided by 6 is 210. So that one is correct. 11 times 180 divided by 6 is 330, not 300. So this is not a correct statement. It should have been 330, not 300. Statement 2, they are all part of a solution set pi on 6 plus 2 pi n. Well, that's not true, because if you add 2 pi n, which would be 12 pi on 6's, that would give you 13 pi on 6 as the next one. So you skipped all of these. It's not a true statement. Statement 4 is correct, because pi on 6 will be in the first quadrant, 5 pi on 6 will be in the second quadrant, and our cast rule tells us that sine is positive in those 2 quadrants. You could also use your calculator and find the value of the sine of pi on 6 and 5 pi on 6. You'd get a positive decimal. So the statements that are correct are 1 and 4. Again, it doesn't say respectively, so you could put 4 and 1. the computer would be programmed to accept either 14 or 41. Okay? Number 14, for that function, the range is between -4 and 10. What are the values of a and d? So this tells us that we have a minimum of -4 and a maximum of 10. You might remember that the d value is the horizontal midline. It's halfway between the min and the max. It's the average between the min and the max. We can find d by taking the average between the min and the max. To get average, you add the numbers up and divide by how many there are. So that'll be 6 over 2, which is +3. So that's our horizontal midline at +3. It's halfway between the min and the max. It's 7 units away from them both. Question? Jordan, you okay?
I'm just confused because
You're good? Okay. And again, 3 is halfway between -4 and 10. It's 7 units away from both of them. It's halfway. It's the middle. Now, A tells us the amplitude. It tells us how high above the min we go to get to the maximum, or how low below the middle we go to get to the minimum. If the middle's at 3, we have to go up 7 to get to 10, down 7 to get to -4. So A is 7. And you can actually find A by going max minus min over 2. It's not on the formula sheet, but it does work. 10 minus -4 gives us 14 over 2, which does equal 7. So the values of A and D would be 7 and 3, but because it doesn't say respectively, the computer would also be programmed to accept 37. Number 15 is a standard of excellence question. What is the phase shift and period? What makes this a standard of excellence question is the phase shift is your C value, and to find C, B must be taken out as a common factor. That's what makes this a standard of excellence question. You must take the 3 out as a common factor to get the correct C value. So the phase shift would be pi on 3 left. That's our h value. And remember, the general form is x minus h. The value of h is always the opposite of what it appears to be. In this case, it would be -pi on 3. And remember, our period is always 2 pi over b. Our b value is +3. So that is our period. So the period equation is not on the formula sheet. Right? That is 2 pi over b. But remember that b causes a horizontal stretch. And if the b value is 3, we learned that the horizontal stretch is the reciprocal of b. So this would have a horizontal stretch of 1/3. Normally, the period for sine and cos is 2 pi. This has to be 1/3 of that. That's where the 2 pi over 3 comes from. Given that cos n theta has the same period of tan theta, what is the value of n? Well, you have to remember that the period of tan theta is pi radians. Normally, the period of cosine is 2 pi. In this case, we want it to be pi. So it has to be horizontally stretched by a factor of 1/2. To go from a period of 2 pi down to pi, we horizontally stretch by a factor of 1/2, which means our b value has to be 2. because B and the horizontal stretch factor are reciprocals of each other. So our answer would be 2. So this next question, we've got a partial graph of that cosine function. There's a minimum value at pi on 2 comma negative 2 and a maximum at pi comma 8. So that's this point down here. That point is pi on 2 comma negative 2. This is pi comma 8. We want to write the equation of that graph in the form a cos bx plus d. So there is no phase shift here, which if you remember what the characteristics of the cosine graph, it started at the maximum, which this one does. Here that would be the point 0 comma 8. So there's no phase shift here, and that's why there is no c in that equation. So we need to figure out the values of a, b, and d. Okay, well, d is easy because remember it's halfway between the max and the min. Our maximum value is 8. Our minimum value is negative 2. That's a distance of 10 units. So our horizontal midline would have to be halfway in between, 5 units from each one. So from negative 2, if we go up 5, we'll be at positive 3. And if you start at 8 and go down 5, you're also at positive 3. That is our d value. D tells you the horizontal midline. And the amplitude is the distance from that midline to the max or down to the minimum. That distance is 5 units. From 3 up to 8, you're going up 5. From 3 down to negative 2, you're going down 5. A, our amplitude is 5. So the only thing we have left to do is find out what B is. So let's look at the period of this graph. The period of this graph is pi radians. That's how long it takes to go through one cycle, from one maximum to the next. Normally the graph of cosine has a period of 2 pi. This one is pi. It's half. It's been horizontally stretched by a half. Which means our B value has to be 2, because the horizontal stretch factor and the B value are reciprocals of each other. So our equation now will be y equals a is 5 cosine of b is 2 and d is plus 3. There's that equation. And it does ask us to state what a, b, and d are, so it would be 5, 2, and 3. Chances are a question like this, they probably would say respectively, because the number of combinations or permutations, I should say, of those 3 numbers is more. It'd be 6 different permutations, so they'd have to program the computer to accept 6 different codes. So for something like that, again, they probably might tell you to write them in that order. So use the information to answer the next question, which is basically how many true statements are there for that graph. So you've got the equation. Remember that the amplitude is the absolute value of A. So in this case, the absolute value of negative 3, which is 3. The negative sign in front of that 3 tells us that the graph was reflected over the x-axis. It doesn't change the distance from the middle to the max or the min. That will be 3 units no matter what. So statement 1 is correct. 2 says that you can find the maximum by going d minus 3. Well, no. You would go d plus the absolute value of 3 is what you would do there. Okay? Because you go d plus the amplitude. And this is saying d minus the amplitude. So that is an incorrect statement. The period is 2 pi. Well, that's not true either. Our period, remember, is always found by going 2 pi over b. Our b value here is 2, which is pi radians. So that is not a correct statement. When compared to the graph of negative 3 sine 2x plus d, this graph would be horizontally translated 5 units to the right. Well, that is a correct statement because when x is replaced with x minus 5, that means h is positive 5, and it'll go 5 to the right. The last statement, if d is greater than 3, it will have no x-intercepts. That is also a correct statement. If d is greater than 3, that means the graph has been shifted up more than 3 units. The amplitude, though, is 3, which means it'll go down 3 units below the middle. If d is greater than 3 and it's been shifted up more than 3 units, it'll never hit the x-axis. So in this case here, we have 3 correct statements. So C was the answer. This next question is based on that graph. It shows the height of a Ferris wheel h meters above the ground as a function of time in seconds. The maximum height is 17 and the minimum is 1. So that's 1, that's our maximum or minimum. Our maximum height is 17. We want to write the equation as a function of time t in that form as a cosine function. So the period is 30 seconds. It starts at the minimum. The next time it gets to the minimum, it's 30 seconds. So halfway between that will be where the maximum is, which is at 15 seconds. So this point here would be 15, 17. If you go from one minimum to the next, halfway in between those will be where the maximum is. Our d value is halfway between the max and the min. The maximum is 17, the minimum is 1. That's 16 units apart. Half of that is 8. That's where our horizontal midline is. That is our d value. A is our amplitude. It's the distance up to the max or down to the minimum from that horizontal midline. So that would be from 8 up to 17 is 9 units. No, that's not right. This should be 9, not 8. 17 maximum height is 17, so that is the right height. The minimum height is 1. 17 minus 1 is 16, so it's 16 units apart. And half of that would be 8. Oh, I'm sorry, 8 units away from this, not at 8, but 8 units away from that, or 8 units above 1. So it actually should be at 9. I apologize for that. Half of 16 is 8, but that's how far it is away from the max and the min. 8 units above 1 is 9. 8 units below 17 is 9. So from 9 down to 1, it's 8. That is actually our amplitude. Or from 9 up to 17, it's also 8. So our amplitude is 8, which is what A is. So now, let's find our B value. B comes from the period. Our period is 30 seconds. Remember that period is 2 pi over B. Our period is 30 seconds. So we just need to solve for B. We can make both sides a fraction and cross multiply. 30B will equal 2 pi. So B will equal 2 pi over 30, or pi over 15. There's our B value. And our C value will be 15. Cosine starts at the maximum, and the first maximum point is point 15, 17. So our C value is 15. We can now write this equation, right? We found A to be 8. Our B value is pi over 15. T minus C, which is also 15, plus D, which we found to be plus 9. So there's that equation. There's that equation. Number 20, we want to solve that equation for theta between 0 and 360 degrees. Note that 0 is included, 360 not. So that tells us that we have to give our angles in degrees, and to do this, we will factor. There is a common factor of cos theta there to take out. And our solutions will come when each factor equals 0, which will be where the cosine of theta equals negative 1/2. For this, we will use the unit circle. So let me just back up. I'm going to grab the unit circle that we created way back. There it is. So the cosine of theta, which is the x value, equals 0 up here. That's at 90 degrees. But it would also equal 0 down here at 270 degrees, because down there the coordinates are 0, negative 1. So there's our first two answers. Theta will equal 90 degrees and 270 degrees. The cosine of theta equals positive 1/2 up here with a reference angle of 60 degrees. For negative 1/2, we have to be in the second or the third quadrant. That's where cosine is negative. With a reference angle of 60 degrees, it will be 60 degrees short of 180, which is 120, and 60 degrees past 180, which is 240 degrees. So there's our two answers for that factor. You can always check these. In this case, our angles are in degrees, so we need to be in degree mode. If you do 2 times the cosine of 90 squared plus the cosine of 90, you get 0. If you do 2 times the cosine of 270 squared plus the cosine of 270, you get 0. So now we'll check 120 degrees and 240. They all work. You let theta equal each of those 4 angles, you do get 0 as an answer, which is what the equation says you need to get. So those are the solutions between a specific domain. Question 21, we're asked to find the general solutions. So that is where the domain is from negative infinity to positive infinity. This is where we use multiples of the period. But first we have to get the tan of theta by itself. So tan squared theta would equal 1, and then tan of theta, by taking the square root of both sides, would be at plus and minus 1. So that happens when you have a reference angle of pi on 4, because the tangent is sine over cos. To get 1, the sine and cos have to be the same, and that's at pi on 4. So you're going to have an answer in the first quadrant and in the second quadrant at 3 pi on 4, and those are 2 pi on 4 or pi on 2 radians apart. And every multiple of pi on 2, you will end up with sine and cos values that are the same, except one might be positive and one might be negative, which works for the negative 1 answer. So our general solution here would be pi on 4 plus n pi over 2. Every multiple of pi on 2. And then you also have to say that n is an element of integers. That would be the general solutions to that equation. For number 2, you want to solve that one between negative pi and positive pi. The problem with this, and this is why it's a standard of excellence, is that you've got 2 different trig functions there. You've got cosine and sine. But you can write that first term in terms of sine, because cos squared x would be 1 minus sine squared x. That comes from the Pythagorean identity, that sine squared x plus cos squared x equals 1. We use that one lots. So now if you multiply out the bracket, now we have only one trig function identified here. I would move everything from the left over to the right because I want the sine squared x to be positive. So you're going to subtract the sine x from both sides. 2 minus 1 is 1 on the left. You're going to subtract it. It will become minus 1 on the right. So that's the equation that we're now going to solve by factoring. So it would have to be a minus 1 there and a plus 1 there to give us minus 1 sine x in the middle. And our solutions will be where each factor equals 0, which will be where the sine of x equals negative a half, and where the sine of x equals 1. So, from the unit circle, the sine of x equals a half with the reference angle of pi on 6. In this case, our answers have to be between negative pi and positive pi. So let's just draw for negative 1/2. Again, that's a reference angle of pi on 6 from the unit circle, but sine is negative in those bottom two quadrants. So we would have to be here and there, with a reference angle again of pi on 6. That's where sine is a half. So in this case, our two answers will be negative rotation angles. This first one in the fourth quadrant will be negative pi on 6. This one in the third quadrant will be a pi on 6 short of negative pi, or negative 6 pi on 6. That will be negative 5 pi on 6. It's 1 pi on 6 short of negative pi, or negative 6 pi on 6. So there's your two answers where the sine of x is negative a half between negative pi and positive pi. Finally, where the sine of x equals 1, the only place that'll happen will be up there, which is positive pi on 2. So there's the three answers. Now again, you can check these in the calculator. Now we have to be in radian mode because our angles are in radians. If you do 2 times the cosine of negative pi on 6, close the bracket and square it, plus the sine of negative pi on 6 minus 1 does equal 0. So that one checks. Checking negative 5 pi on 6. I have to insert a 5 there. And insert a 5 there as well. That one works. The last one is pi on 2. There's pi on 2 in there, and it works. Right? So you can always check these. Always, always. So number 23 is already factored for us. Our solutions will come when 2 minus root 3 of secant theta equals 0, and when secant theta plus 3 equals 0. So if we solve for secant theta in this first case, by adding the root 3 secant theta to both sides, and then dividing by root 3, that's what the secant will equal, and the reciprocal of secant is cosine. The cosine will be root 3 over 2. For the second factor, that's where the secant of theta equals negative 3, or the cosine of theta equals negative 1/3. This first one is on the unit circle. Here we just want our answers between 180 and 360 degrees. If we look on our unit circle, the cosine is root 3 on 2 with a reference angle of 30 degrees. That's pi on 6 radians. And in this case, there's only one quadrant we can be in, which is the fourth quadrant, and that comes from our cast rule. The cosine of theta must equal positive root 3 over 2. In the third quadrant, our t quadrant, cosine is negative, not positive. So it can only be in this first quadrant with a reference angle of 30 degrees, which means it's 30 degrees short of 360, so theta would be 330 degrees. For this next one, In this case, we have to be in the third quadrant because that's the only quadrant between 3 and 4 where cosine is negative. And nowhere on the unit circle does the cosine of theta equal 1/3. So in this case, we find our reference angle by going second function cos of 1/3. But we have to be in degree mode and go second function cos of 1/3. This gives us our reference angle. It does ask us to state to the nearest degree, so that would be 71 degrees. That's our reference angle. So this angle is 71 past 180, which is 251 degrees. Okay, I'm going to stop there. We will finish this package off tomorrow and then, Monday. And then we'll also go through the trig exam that you guys wrote. So remember that tomorrow's the last day to hand in any missed assignments. Monday at lunch is your opportunity to rewrite the Unit 3 reassessment. Again, machine scored only. Wednesday will be your chance to write the trigonometry reassessment. I will put the Unit 2 assignment up here so that if you want to start working on it on the weekend, you can. Any assignments that you finish tomorrow, scan them and email them to me. I'll print them off and mark them. Your diploma exam is next Friday, a week from tomorrow, 9 a.m.